Welcome to Brain Vision.
In this problem, we have to find out the value of this IA, I small a capital A, IBB, and ICC, right? So, or you can say that we have to find out the line currents. So, as you can see, the impedance in each branch is same, right? So, we can see that the loads are connected in the, this is the neutral point. So, the loads are connected in the balanced Y connection. Similarly, if you look at over here, that's why I have not written all the impedances, because the value of each impedances is same. So if I am interested to find out the value of impedance across this A and N, so what I can do is, if I write, let's suppose this is our ZA, so the value of impedance will be, as both of them are in series, so we can easily add both of them. So what I will do is, impedance will be 24 minus 15 j ohms. So this will be the value of impedance, and this will be same throughout each branch, right? So now, if I will look at the given values, so the given voltage, that is VAB, the voltage across this A and this B point is given as VAB, and the value of VAB is also given, which is 25, uh, sorry, 125 angle 0, 125 degree, 125 angle 0 degrees volts, right? So our aim is to find the value of IAA, that is the line current, and as you can see over here, this is the balanced I connection. So if we find one of them, we can use the property of balanced I connection, that is the line currents. Let's suppose this is IAA, the magnitude of all the line currents will be same, right? So if I writing over here IAA, and this will be IBB, and the third one is ICC, and the magnitude of all of them will be same, but the phase difference must be as 120 degrees, right? So the phase difference, if I say, that is phi, must be is equal to 120 degrees, right? So if I will find one of them, then I can apply this rule to find out the remaining ones, right? So let's find out the value of IAA. So as we can see, the value of IAA can be found with the help of the formula, which is the value of VA, or if I say the phase voltage, so value of phase voltage, suppose this is A, because this is the phase voltage across the phase A. This is our phase A. So the if the value of voltage across this is VA, so this will be VA upon ZA. Or as we have the value, we don't have the value of VA, that is the phase voltage. So we have to find out the phase voltage with the help of the line voltage, and the formula for the phase voltage with the from the line voltage is, VA can be written as, VA is equal to VAB, that is the line voltage, by root 3, and the angle, this will be lagging from VA, that is the VAB, that is the line voltage, by 30 degrees, right? So if we put the value over here, we have the value of VAB. So if I will put the value, what I will get is, see, and the value will be, VA will become as 125 by root 3, and as the angle is 0 degrees, so we can directly write it as angle minus 30. So this will become minus 30 degrees. So if we simplify, we will get the value of VA, which is 72.17 angle minus 30 degrees. So this is the value of VA. Now if I put the value of VA, the this formula, I will get the value of IAA, that is the line current. So let's put the value over here. So the value of IAA will be 72.17 angle minus 30 degrees over the value of impedance, which is 24 minus 15J, which is written over here. So I'm just putting the value over here. So the value will be 24 minus 15J. So if we calculate, if we convert this the impedance into the polar form, what I will get is, this will become minus 30 degrees upon 28.30 angle minus 32 degrees, right? So if I divide it, I will get the value of IA, which is 2.55 angle 62 degrees. So this is the value of IAA, which is the one of the line current. And as I already told that the value of another current, the magnitude of other remaining line currents will be same. So, but the phase difference must be 120 degrees. So what I can write it as, so that in the question, it is given that the phase sequence of load is the positive phase sequence, right? So it means that the current IAA will be lagging by IBB by 120 degrees, right? Similarly, the current IAA will leading from ICC by 120 degrees. So what I can do is I will write the value of IBB, which will be IBB, which will be the same, magnitude will be same, so that will be 2.55, but the phase difference must be of 120 degrees, and this will be leading by 120 degrees. This will become 120. The final value will be 2.55 angle 182 degrees ampere, right? So this is the value of IBB. And similarly, if I will go for ICC, what I can write is, I can simply write the value of ICC as, the value of ICC will be, the magnitude will be same as IA, which is 2.55, but the phase difference must be 120 degrees, and this will be lagging by 120 degrees. So this will become 62 minus 120 degrees, and the value will become, again the magnitude same, 2.55, and the phase difference will be difference of these two, and this will become minus 58 degrees ampere. So this is the value of ICC. Value of ICC is this. This is the final answer. So that's it for that.